Okay, this is how to control a relay. Now, what is a relay? A relay is a component which allows two independent circuits to be connected together. How does it do it? It does it through an electromagnet. So we're going to get a reasonably simple relay, which is this one. I'm just going to spin it around, and I'm going to put it here, and I hope that doesn't confuse you. But it's not going to be connected to this circuit. The way it is connected is the circuit is connected to the electromagnet. And so the electromagnet, opposed to someone pushing a switch backwards and forward, the electromagnet controls that switch. Okay? And so that's how you can get a very low powered circuit controlling effectively, like a mains powered circuit, which is quite good. And it means that if we have something like a motor, which takes quite a lot of energy, it means that we can combine it with a Genie circuit, which the Genie doesn't take that much energy. What can happen is when you include a motor in a circuit, the motor absorbs so much, it's so hungry for electricity, all of the energy goes to the motor, and the Genie gets a significant drop in voltage and therefore turns off or restarts. Anyway, let's just start this up. We've got the relay there. And just like last time, what we're going to need is a transistor. And it's a transistor that needs to be connected to the relay or the load. Do you remember we said the load goes before the relay? Before the transistor, like last time. And what we're going to do as well is we are going to take this one, which is Q3, and we're going to connect it to, here we go, we're going to connect it to, we're not connecting it to there, we've got to connect it to the transistor just as we did before, to the base of the transistor. There we go. So Q3 now is connected to the base of the transistor. Just like before, we need to take the electromagnet high, and then which is effectively the collector from the transistor, and then we can take the emitter low, and just so you can see, that's the low there and that's the high there. Okay, so now we should be able to flip this on and off, and that's what I'm going to just see if I can do with Q3. You see I'm flipping it on and off, little paddle. So now, of course, it's not actually connected. Okay, so it's the electromagnetism which is flipping that backwards and forwards. So now, of course, what I can do is I can get some more power, put that in. That's my preferred way. I suppose it's an output component, is it? I don't think. Oh, here we go. Motor, DC motor. Put that in. That's a 3 volt. Let's go to a 6 volt. Oh, 4.5 volt. And then if we connect this up to here, and then if I connect the motor, can you see to there? So it will flip over it and it will make the circuit, and that will mean the motor will spin. So let's just have a look at that. We go down to D3, wasn't it? I think that is D2, D3. You see that? And the reason it's doing that backwards and forwards is because it turns itself on and then off. If we just have a look at the coding, it turns itself on and then it turns itself off, then it turns itself on, and it turns itself off. I mean, I suppose if we were to get rid of that timing command there and then go back and do it, it might. Yeah, it does flip back a little bit, but you can see it's a lot less. So I hope that helps. So what have we got here? We've got the 426s, we've got the 417s, we've got the motor on the relay, and we've also got the buzzer. So that will help a lot of you with your circuit diagrams and problems that you're having. And yeah, hopefully it means that you will have working circuits.